On behalf of the Environmental Finance Center Network, I'd like to welcome you to our webinar entitled Aging Infrastructure, What It Is and What to Do About It. Okay, now it's my pleasure to introduce Heather Himmelberger, Director at the Southwest Environmental Finance Center at the University of New Mexico, and Dawn Nall, Program Manager for the Environmental Finance Center Network. Take it away, Heather.
Hi everyone, and welcome to today's webinar. It's a first part of a two-part webinar series on aging infrastructure. Today, part one, we're going to talk about what it is and what to do about it. And then in a week, we're going to talk about specifically impact on water loss. This webinar is part of our project, Smart Management for Small Water Systems, that's funded by EPA. This project includes in-person trainings, webinars, one-on-one assistance. It will also include an e-learning module this year that any small water system who would like to can take. A small water system for this purpose is one that's under 10,000 in population. If you want to find out what trainings we have available, and we will have at least one training in every state, and we will have trainings in each of the 5 territories as well. If you'd like to find out what's upcoming with our trainings or with our webinars, please log on to efcnetwork.org, the website that's in the green circle up above. Or you can just use Google to search for Environmental Finance Center Network and get to our website. We have many resources available on that site, as well as blog posts and all kinds of things. And our project is related to managerial and financial capacity. So I want to talk just for a moment about what subject areas this grant covers. The first one is asset management, and I kind of put this one first because I sort of see it as an overarching area that kind of encompasses many of the other managerial and financial areas. We're going to talk a little bit more about this later, but there's 5 main components to asset management that you see in the 5 cylinders there. And if you think about other topics like energy efficiency, it ties very directly to these asset management topics. When you're doing your asset inventories, it's very important to find out which assets use energy, because when we know that, we can make different choices about how to repair or replace assets, because you might want to replace an asset with a more energy efficient asset, which will then cut the costs of your overall funding. And energy has a large part to do with how much the operation is going to cost. So again, it ties very directly to how much funding you need. When we look at water loss, that ties to the condition, which is part of the current state of the assets. It ties to level of service, meaning what are you actually trying to provide for your water customers. If you're in a drought or a water scarce area, you might set a level of service related to how much water loss you'll accept within your system. And then finally, it relates to long-term funding, because when you produce water that isn't delivered to your customers, you have to pay for that water and find a way to recover the revenue that you're not going to receive from sending it to customers. Another one of our areas is rates and finance. And this ties very directly to long-term funding, because most of water utility funding comes from the rates that customers pay. So we have to figure out what customers are going to pay, and then that will tell us how much funding we have to really do all the other aspects of our asset management program. So it's very important to know what funding is available. We're also working in water system cooperation, which means any way that a system might want to work with somebody else. It could be anything from just sharing information, going to water trade organizations and that type of thing, all the way up to sharing operators, sharing management, and then finally maybe interconnecting with others. And that can impact all of the various areas of asset management. If we just look at energy efficiency and water loss, they're very directly connected, because it takes energy to produce the water that's then lost out the pipe. So if we can cut our water loss, we can cut our energy usage. Both of them are related to the rates because they're controllable costs. If we can affect energy use or reduce water loss, we can reduce the amount of money that's required to run our system, or if we keep our revenues the same, we have money to do other things. And then finally, Small water systems don't have the same economy of scale as larger water utilities, so cooperating with each other is one way that smaller water systems can achieve some of that economy of scale and cut the costs of operation. Later on in the webinar, you'll get a chance to request assistance in any of these areas, so I wanted to kind of go through what some of the areas involved. So back to today's topic, aging infrastructure, what is it and what to do about it? So do any of these sound familiar? America's infrastructure is aging. How will we deal with aging infrastructure? We have a problem with aging infrastructure. There's a lot of talk right now about infrastructure aging, particularly related to transportation, but certainly related to water and wastewater as well. You might also be familiar with the American Society of Civil Engineers Infrastructure Report Card. They evaluate infrastructure in many, many different categories across all 50 states. And then they publish every couple of years an infrastructure report card. You can access the report online either at the link that is provided there or by just typing in the Google infrastructure report card. It's very easy to find. And then you can go through and look at what the grade is for your state and what information is provided. For the nation as a whole, they gave the grade of D for water infrastructure. So if you think about what a D means, you're just one step above failing. So what does that really mean for us to hear that the water infrastructure is a grade D? Is that telling the whole story? Well, one thing we have to think about is the fact that they've aggregated the entire country together in one grade. So that's really going to skew the results when you think about the fact that there's 170,000 roughly water systems across the whole country, including your community water systems, non-transient, non-community systems, and transient non-community systems. And there's about 60,000 or so that are community water systems, and we're putting them all together and giving one single grade for the whole country. So that's going to obscure what's happening in different regions of the country and within different systems. The other thing we have to think about is how do we reconcile this grade D with what we're telling our customers and what our customers are seeing. So our customers are turning on the tap, water's coming out, it's good quality, it's reliable, it's at a good pressure. In almost all cases, we have extremely low rates of waterborne illness, very few deaths at any time from waterborne illness, only a couple a year. In fact, I looked up the CDC statistics, and there's only been a few related to Legionella. So on the one hand, our customers are seeing a great system, and on the other hand, we're telling them that our infrastructure is a grade D. So we kind of have these mixed messages. What I like to think of it as is we have avoided investing in our infrastructure for quite a while. We've not been charging a lot of money for our water, but we're really, really good as operators and managers at making water systems work. So that's part of the story, is even if the infrastructure starts failing, we're still able to do a good job at making it work together. And we may not be clear about what we really consider as bad. Like when we give it a grade D, we may be expecting more, we may be grading our infrastructure a little lower than it actually is. So we have to sort of think about the whole story here. Is we have been able to make things work, but we may be on the precipice of how much longer can we really deliver the kind of services that our customers want. So we've been doing a good job so far, but how much longer can we keep this up? Because on the other hand, our infrastructure is wearing out and will eventually need to be replaced. It's just a matter of when. So just like us, we won't physically live forever. So is true for our infrastructure, that eventually at some point in the future, all of this infrastructure will have to be replaced with something else. So maybe the best way to think of the D is we have still been providing a good level of service, and if we want to continue to do that, we really need to look at our infrastructure and see what we can do to ensure that it will meet our customers' needs. So when we think about aging infrastructure, a couple things that I want to talk about today is, what does aging, the word aging, really mean? We need to think about individual assets versus our whole system. Think about all of our asset classes. The D grade from the ASCE is primarily being driven by pipe, by water pipe, which of course is a huge part of a water system, but it's not all the water system. So we want to think about all classes of our assets. We need to think about evidence-based decision-making rather than just what is our gut reaction telling us. If we hear that America has a grade D, do we automatically assume that our water system is a grade D also, rather than checking and seeing what's actually happening in our system? And then finally, even with aging assets, not all the assets' performance is going to be the same. So we're going to do a little poll question here, and we're going to ask you what characteristic best defines aging infrastructure. So Lisa, if you could start the poll, please.
Here it comes.
Okay, if you just take a minute and look at the poll question, what I'd like to know is what characteristic do you think best defines the aging infrastructure? And we're thinking about, is it the age of the infrastructure, useful life, material of manufacture and installation, or are you not sure? So just take a moment and just choose what you think would be the best characteristic to define aging infrastructure.
Just going to give it a few more seconds to allow people to respond. Okay, and I'll close the poll at this time. And here are the results.
All right, so we have age of infrastructure 11, useful life 77, material 9, and not sure 3. All right, so if we can go back to the presentation. So you guys must have taken this course before. You were absolutely right. What we're really talking about is the useful life. Age in and of itself is not the best indicator of aging infrastructure. So when you hear things like, well, we put this infrastructure in, 1930 or 1950, that's not the important part. The important part is that asset able to still continue to deliver the service that we want? So we really want to get away from just strictly thinking about the age of the infrastructure and think instead about the useful life. So let's talk a little bit about what goes into an estimate of how much useful life an asset might have. So we're going to think about a couple of things. Like, one is, what do we want the asset to do, and can it still do that? And we'll talk a little bit more about that in a minute. We want to think about the condition of the asset. How is it? Is it corroded? Is it degrading? Is it in good shape, bad shape? We want to think about the materials, manufacturing, installation, so all those kinds of issues about the actual product. And if you think about some of that, the manufacturing techniques in particular with pipe can be a big thing, because cast iron pipe has been made different ways. So the very old cast iron pipe is much thicker in the wall diameter, or in the wall thickness, than the newer cast iron pipe. So it takes longer to degrade through some of that pipe, and it had to do with how they were able to manufacture it before versus now. So that can have a big impact. How it's installed can have an impact. We want to think about, what did the manufacturer tell us we could expect to get out of that particular asset? And that will be affected by the three things that are listed below that. The usage history. How have we used that asset? So does that match what the manufacturer expected the level, the service to be? Are we trying to pump more water, or at a different head or pressure or whatever than we should? What kind of water's been in there? What kind of environment has it been in? That can affect the life, either making it longer or shorter. The maintenance history. If we haven't done any maintenance, then the manufacturer's estimate of length of service may not be, we may not see that because we didn't do any maintenance, because typically they expect that you will have done at least the bare minimum maintenance. If you do more maintenance, if you're doing better with your maintenance, you may go way beyond what the manufacturer's estimate is. And then finally, the repair history can tell us a lot of information about how that asset is performing and how much longer we can expect it to perform. So let's just go back to one aspect of the useful life that we skipped over a little bit, is what do we want the asset to do, and can it still perform at those levels? That's a big part of our useful life consideration, is, you know, what are we actually expecting out of that asset? So there's a couple of examples here, like, you know, if we're trying to maintain a minimum pressure, can the assets that are involved in that actually deliver that kind of pressure? If we have piping, we may have something like the number of breaks per mile of main, or we may have number of service interruptions per customer per year, and that might be a metric to tell us, you know, is the pipe reaching the end of its useful life? And we can always adjust those things if we think we're not giving enough breaks, or, you know, customers can tolerate more interruptions. Then we can run our pipe out longer. If we want to have fewer of those, we would shorten the life of our pipe. And then finally, meeting regulatory requirements is another thing that has more to do with our other non-pipe assets. Is, you know, those are our treatment assets, our disinfection assets, and are they still able to perform at those desired levels? So that's a big part of the useful life, and we need to figure out for each asset what that life is going to be, how much longer we think that asset can remain in service and still meet what we want it to do. Another consideration with the aging infrastructure picture is we want to view our assets individually and not as an aggregate. We don't want to think of our system as a monolith, as it's all one and the same. We didn't put in our systems that way, at least not for most systems. We usually put them in over time. We put in pieces of pipe or parts of our treatment system. We may have added to our treatment system. We may have added wells or tanks. And so we need to look at each of those assets individually, because the useful life is not the useful life of the entire water network. It's the useful life of each particular asset. And that will help us later when it comes to replacing our assets. We can pick out individual assets that need to be replaced instead of replacing an entire system. We want to think about the fact that asset performance is related to each individual asset. So even assets within a class, or even assets that were put in at exactly the same time, can perform very differently. And why might that be true? Well, they could be subjected to different environments. They could be subjected to different service requirements. If it's pipe, it could be in different soil conditions. It might be under different kinds of road conditions. The other utilities that are nearby might be different. So there's a lot of reasons why assets can perform very differently. And why does that actually matter? Well, the reason it matters is when we actually estimate useful life and decide when to replace something. Again, we don't want to say, well, let's replace every piece of pipe we put in 1920. We want to say, well, out of that 1920s pipe, what is the pipe that's not performing well? Because there may be some that's performing very, very poorly, some that's performing very, very well, and some in between. So we really need to look at, in our individual systems, what is it that causes our assets to perform differently at one place than another. And that will be very, very system specific, and it will change based on where you live in the country, because weather can impact how deep your pipes are buried. You know, all those factors can impact your asset performance. So you really need to look at, again, you know, going back to the issue that we don't want to just use a gut reaction. We want to have data-driven decisions. We want to think about what is it in our systems that makes our assets perform differently. And then just to remind everybody what classes of assets are, it has to do with the type of assets that we have, where we might have tanks and pipe and hydrants and pumps. So within the class, we want to separate our system into the classes of assets. And I've kind of put more the horizontal assets on the right, which are the things that are in the field, and the vertical assets on the left, which are the things that usually are related to treatment and water supply. So we want to know the classes of assets that make up our system, and then the individual assets within those classes, so that we can really figure out what to do about our assets. The more we know about the individual assets and classes, the better off we are later on. So here's another poll question. For your individual systems, what types of assets are most concerned to you? So if you could open the poll, Lisa. Okay, so there's a couple different choices. Water distribution piping, storage tanks, wells, surface water intakes, treatment system components, and then a choice for other if there's something else, or if you don't operate a water system, you can choose the other. So this is just a chance to say, you know, what are the kinds of things that you're worried about in your system, just to get a feel for, you know, for the folks that are on the webinar today, what items are most concerned to you.
Folks are still clicking in, so I'll give it another few seconds.
And I'll just make one more comment that I forgot to make sooner. For the folks that are listening in today, there are opportunities to receive CEUs from AWWA depending on your state. Some states allow CEUs for webinars and some do not. So there will be directions for how you can generate a certificate of attendance and check with your state to see if they will accept CEUs for the webinar. So while we're waiting for people to click in, I just wanted to let you know.
Great. Here are the results.
So not tremendously surprising, about half the folks have water distribution piping issues. And since piping is a huge part of any water system, and even more so for small water systems, not too surprising. Then we have 6% storage tanks, 10% wells, and 9 treatment components. And then 26% other or not operating a water system. So that's not tremendously surprising to see, given that water piping is one of the bigger infrastructure components. Okay. So moving along, we've talked a little bit about what aging infrastructure is, and it's basically when your treatment or when your water system components are reaching the end of their useful life. So that's the way we want to think about it. It's those components that are reaching the end of their useful life. Well, what do we do about it? Oftentimes we view this as kind of a choice between two extremes. And we're going to talk about what those extremes are. The first one being we're going to replace all the infrastructure. So the idea that I believe my system is, quote, aging, I need to do something about it, I'm going to replace the whole thing. So this is going to be, you know, take some money if we're going to do it that way. And I kind of liken this a little bit to if you have a car and you get a flat tire, you're going to get rid of you're going to get a brand new car because you feel like since the tire went, everything is going to go. So we want to think a little bit about what that means. And here's an example system. This is a real system, but we won't use their name today. It's a very small rural water system, and they were concerned about aging infrastructure. They thought that their piping network was really starting to fall apart. They thought they were having a lot of problems with breakage, and that the system was old, deteriorating, and needed to be completely replaced. They were pursuing funding for a project at $5 million to replace all their infrastructure piping. So then the question became, is replacement of their infrastructure piping actually necessary? And what we ended up doing is, instead of the gut reaction, which was, yes, we need to replace it all, we dug in and did some data-driven decision making. So we looked at the pipe network and said, well, how many breaks are they really having? They didn't have good records for that. We had to generate those records. We found out they really didn't have very many breaks at all. They only had a few breaks each year. And it turns out that they were related to generally one of two things. One was construction accidents where their streets were actually dirt, so it was easy to pull the pipe out of the ground. With people digging for various projects, they would pull the pipe out and it was breaking for that reason. And then another reason was they had a elbow that wasn't thrust restrained properly, and there were several breaks there. The pipe was not deteriorated. It was actually not even all that old. It was about 30 years old, and it was actually in pretty good shape, and they weren't showing any signs of deterioration related breaks. So what we discussed with them was the fact that that really wasn't the project they needed. We talked about some other issues the system was having. There were some issues related to lack of loop lines, so dead ends were causing water quality problems. They needed some more valves. So there were a couple of things that they needed to do with their system. They ended up doing a project that was about a $50,000 project, putting in some loop lines, some hydrants, some valves, and had a much better system and avoided having to replace all of their piping infrastructure now. So the question becomes, what are the consequences if they would have done that early replacement? The main consequence is spending money you don't need to spend. So if you're a small system, there are subsidized funding sources, either grants or loans or combination of grants and loans. If you were to get a grant to do that, what you're doing is spending money where it doesn't need to be spent so that it can't be spent somewhere else. If it's a loan, you're burdening your customers with money that they don't really need to spend. So that's why it's so important for us to really be data driven. Like, just because ASE says the grade is D, we shouldn't automatically assume this end of the spectrum of saying we need to replace all of our infrastructure now. We really want to be data driven and think about, what is the useful life of that asset, and their useful life of their piping was at least, decades more. They weren't really needing to replace it now. So let's look at the other extreme, which is probably more common, and we'll do a poll question about this in a little bit to find out, based on the people who are on the phone. The other end of the spectrum is, let's push off infrastructure replacement, or let's ignore the need for replacing any of our infrastructure. So the example I have here is one that you might remember. This is the Los Angeles break that occurred right beside the UCLA campus. And you have to remember that they're in one of the worst droughts that they've ever had, and this break lost them about 20 million gallons of water. So there's quite a bit of water that went out through this break. And their question is, what's their replacement cycle? Meaning, how long did they think the useful life of an asset is? And your replacement cycle is sort of a way of you telling others what you think the useful life of your assets is. So the answer is 300 years. They have a cycle where they're investing money in their infrastructure at the rate of replacing piping in a 300-year basis. So each pipe they intend to last 300 years. So the pipe that broke was about 97 years old, and realistically they were going to expect it to be in the ground for another 203 years. It was a riveted steel pipe. One of the rivets broke, and then it was under high pressure, so a bunch of other rivets popped, had a huge gash, and as you probably saw on the news, because it was a pretty big news event, they flooded out an underground parking garage, they flooded a basketball arena, they flooded much of the campus. So there's millions of dollars in damage that is a result, plus they have the damage to the roadway. So when they were asked about it, the leadership said, we can't really drop to 100 years because that's going to be too expensive. So, why did they pick 300 years? They believe it saves them money. So that was their goal, is like, well, if we stretch out the replacement cycle to 300 years, it's going to save us, save us a lot of money. The question is, does it really save you money to put off your infrastructure replacement until events such as the one at the UCLA campus actually happen? So we need to think about, what is the cost of deferred replacement? It's not free. So their attitude, or their underlying assumption in setting a replacement value of 300 years, is to say, if we do nothing but put this off, we don't have to pay anything. But the truth is that when the pipe breaks, it still has to be replaced. So they're actually doing a 4-mile replacement project in that area where the pipe broke. and their pricing is about $550,000 a mile. So they're going to be doing about a $2 million replacement project just for the pipe itself. And then they're having to do it on more of an emergency basis, because now that this has happened, they're going to have to rush in and do it, which makes the prices higher. They have all the damages that have to be paid. They had to pay for about 300 cars. They're going to have to pay UCLA for a lot of the damage on the campus. And yes, they do have some insurance, but there is a high deductible for the insurance. And if you're going to have lots and lots of expensive claims, your insurance premiums are going to go way up. So that's going to be a cost for them. There's a social cost, and in this case it's fairly high because 300 people lost their cars. There were students that were impacted, and people in UCLA that were impacted. There's a drought going on right now where people are getting penalized financially if they waste water, and here's all this water going down the street, so there's that social cost. There's the cost associated with that emergency itself. I mean, they had to have water crews going out to shut down the water. They had to have police directing traffic, so there's those kinds of costs involved. There's costs related to the damage of other infrastructure, such as the road, and in this case, the damage to the UCLA campus. And then there's the cost of the lost water, lost revenue, so the cost related to 20 million gallons of water that didn't get sold. So it's not as if there's no cost associated with waiting till major events like that happen. So the problem is, I might want to live 300 years, but I'm not going to, and they might want their pipes to last 300 years, but they're not going to either. So they're living in an unrealistic arrangement. They're just pushing the costs off to future generations or putting them off to future leaders, because there is a cost to not having your pipe replaced on the right frequency. So I just want to take a quick poll here. Is your utility more like the first case or the second? So if we can start the poll. So I'm asking, would you describe your utility's asset replacement program as similar to replacing all the infrastructure at once, which would be the first case, the small rural community, similar to the approach of a 300-year replacement cycle, more or less, putting off infrastructure replacement? Do you feel like you're replacing an appropriate amount of infrastructure each year? If you're using an asset management approach to infrastructure replacement, like a very data-driven approach to what should be done, and then finally other or not a water system. So what would you describe as kind of your utility's approach to how they're doing the water infrastructure replacements?
You folks are still clicking in, so we'll wait a few more seconds. Okay, and at this time I will close the poll, and here are the results.
So we have a lot that are replacing, well, about 21% that are kind of putting off, excuse me, that are kind of putting off the replacements. 16%, which is great, are doing an appropriate amount of replacement each year, and then we have 24%, fabulous, who are doing an asset management approach, and then 2% are doing something similar to the replace it all at once, and then 36% fall into the other category. All right, so let's go back to the presentation. So if we don't want to replace our assets too early because we'd be wasting resources, and we don't want to replace too late because then we'll have a bunch of other problems, what's really the answer? The answer, and about 24% of you in the poll seem to be using an approach like this, we need to use asset management principles to determine the best time and best way to replace our infrastructure. I mean, that's really where it's at, is we have to figure out what infrastructure is truly needing replaced and what infrastructure we can continue to use going into the future. So I just wanted to go briefly through what asset management is for those of you who aren't familiar with with the program. The first step is to really look at your current state of your assets. What assets do you own? What condition are they in? Looking at the useful life remaining, how much it would cost to replace them. So this is your asset inventory component, because you can't manage what you don't know. So if you know what you have, it makes it much easier to manage it. So so that's one component. The second component is, what do we want the infrastructure to do? We call that level of service. So this is where we set goals for ourselves of, you know, what kind of pressure do we want? What kind of customer service do we want to have? That component. And then how well are we meeting that level of service? The third one is to look at risk, and this is going to be key to what we're going to talk about next, is what's the probability that a given asset will fail, and then what's the consequence if it actually does. And we want to look at each individual asset and rate it so that we can figure out which assets are going to be the most risky for us. And we'll talk in a minute about how that will be a big key to how we decide to replace assets. And then the next step is life cycle costing, looking at how do we want to operate, maintain, repair, replace, rehabilitate our assets as we go forward. So what maintenance tasks are we going to do? How are we going to decide when to keep an asset in service and just repair it, and when we're going to replace it with something else? These are all decisions we'll make during life cycle costing. And then finally, how are we going to fund what we need to do? And we talked about how that relates to water rates pretty heavily, because that's how we get most of our funding, is through charging our customers rates and fees. So one of the key factors, as I mentioned, is risk. So again, risk relates to the probability that a given asset is going to fail and the consequence if it does. So in this particular case, I put the California break back up there again, because it's a really good example of risk. This particular pipe was a riveted steel pipe. If you listen to some of the information that they put out, they said that this particular pipe type caused more dramatic ruptures than other pipe types, such as cast iron or ductile iron, because of the type of pipe it is and how it's manufactured, that it tends to create bigger breaks with more water loss than another kind of pipe. So the consequences were higher. It was a high pressure pipe, so the probability of failure would be a little higher. It was a pipe that had shown some deterioration. So there were a lot of reasons to believe that this particular pipe had a pretty high probability of failure, and it had a very high consequence of failure because of the fact that a lot of water could escape, that it was close to the college campus, that the water would flow downhill into other structures. So this particular pipe would have been one that would rank pretty high in terms of, you know, pipe, a pretty high criticality. I can't say, you know, based on the rest of their network, they have about 7,200 miles of pipe in their system. So comparatively with other parts of the system, you know, I can't say, but certainly it would be a very high consequence pipe or high risk pipe. And what we really want to do is start focusing our decisions on reducing that risk. So if we know that, say, you know, the LA leaders say, well, we can't really do a 100-year replacement cycle because that's $4 billion extra, and we know we don't want to do a 300-year replacement cycle because you're just going to have more and more and more of those events as you go forward, what can we do? Well, one of the things we can do is really look at what's the risk of each piece of pipe. And for the lower risk pipes, we can stretch them longer, not 300 years, but maybe 120, 150. You know, maybe we can keep repairing those lower risk pipes, the ones that won't cause the geyser type breaks, the ones that won't cause as much problem, maybe the lower diameter pipes, the ones that aren't under as much pressure, the different pipe types that cause different kinds of breaks. We can put those replacements off and continue to repair longer, and replace the pipes that we expect to have, major consequences and cause us significant problems. So I think the risk-based decision making is how we get in between. We don't want to be at the two extremes where we're replacing too much or replacing too little. We really want to look at our risk. We really want to figure out which components, if replaced, will cut down the risk for our systems. Now, asset management can help you find those optimal replacement periods and can tell you what to replace when. The trouble is we still need several things, one of which is leadership. The folks in LA, the leaders came out right away and said, look, we're on a 300-year replacement cycle, there's not much we can do about it. Well, it's going to take leadership to actually enact the replacement schedules that we really want to do. There's not really a way around this. We have to step up as leaders, your water utility leaders, and say, look, this is our infrastructure and we need to take care of it. We need community support because we can't do it without the communities. They're the ones benefiting from the water service, and they need to step up as well and say, look, this is a big part of our community, and we need to support the water system. And then finally, the bad news about water rates is we've had low water rates for a really long time. Generally speaking, we haven't kept the rates up with inflation even. Expenses have increased. Regulations have gotten more complex, but we haven't had water rates that have kept pace with that. So now we're facing sort of a double whammy where we haven't gradually increased them, and we have infrastructure that's getting older or decaying that we need to replace, and we are going to have to see water rates rise, and that's really no way around it, as rates are going to have to go up. The drinking water infrastructure is the foundation of the community, and it needs to be treated as such. I believe it's time to start changing the message and letting people know that water and paying for water is an investment. It's not a burden, it's an investment in keeping our families healthy, enabling a good quality of life, providing for the community's economic well-being, allowing for recreation, and keeping the value of property or houses high. I mean, how would you sell your house if there's no water? Where would the jobs come from if there's no water to send to the factories or the manufacturing facilities or any of the businesses in your community? We really need water for all these things, and it's time for us to change that dynamic and say, look, you've really got to invest if you want to keep your community thriving. It isn't going to be easy. I wish I could say that it was, but it's absolutely necessary. It's absolutely necessary for us to take a look at our infrastructure, look at the individual components, figure out what needs to be replaced, and then have the leadership build the community support and raise the rates in order to make that happen, because that's really the best way to move us from a D to a C to a B. I don't know that we ever even need to be an A, but it would be nice to be a C or a B and really have that infrastructure not be on the precipice of causing lots and lots more problems, but rather continue to provide the great service we do to our customers. So just a couple of slides to think a little bit about what you might want to do at your facility. Start thinking in an asset management way if you're not already. Think about your assets individually and how you can assess their useful life. Change how you think about your infrastructure. Think about it not as a collective, but as individual pieces. Seek out asset management training if you haven't had it. We have some EFCN webinars that are already recorded and online that you can listen to. There are in-person trainings on asset management. You can go on our website and find out where they are. If there's one close by, you can attend. There's a lot of online resources on our website for asset management. There's lots of other resources about asset management from EPA, American Water Works Association, and many others that can help you with asset management. Consider ways that you can build community support for the necessary infrastructure replacement projects. We have to change the dialogue with our customers. We have to let them know they are a big part of building the infrastructure that we need to keep their communities thriving, growing, you know, good places to live. And then consider ways that the leadership can be improved. And I mean, getting them to understand the need to step up and really take responsibility, because we can't just push all this off for future generations. I mean, we really do need to start, you know, addressing the problem now, because it's hard to replace lots and lots of infrastructure. And if we don't start with a little bit at a time, it's going to be very, very difficult to do it. Change the mindset as water as an investment in all your interactions with decision makers and the public. I mean, I think this should be something that's key anytime we talk about water. It's an investment. It's not money that's just going away. It's investing in that community, in your own personal family and health and home. So we really want to change that mindset, because that's going to be a big key to trying to get the community support and being able to raise the rates so we can do the replacements we need. And then finally, examining the current rate structure in a complete and thorough fashion. Is it covering your full costs? Is it adequate to cover your infrastructure replacements? Do you need to increase? Does it increase over time? You know, really take a good look at what your rates are now and what they need to be. So our last poll question is really if you would be interested in assistance in any of the areas that we talked about, not just asset management, but community cooperation, rates, energy efficiency, water loss. You can select all that apply in this case. It's not just one answer. And this is something that if you're a small water system, we can follow up with you and see what kind of assistance you need. We do have some ability to assist small drinking water systems with these various areas, and we just wanted to give you an opportunity to request that assistance through this poll.
We'll just give it a few more seconds. Okay, I'm going to close the poll. Heather, do you want to see the results?
No, we'll just follow up individually with anybody who submitted. We'll follow up with you. Okay, just a announcement about a couple of upcoming webinars and trainings. You can see on the screen we have part 2 next week. There's an energy management training, webinar on 12/2. And then December 9th, there's a customer affordability considerations with water rate setting webinar. So any of these can be signed up for on our website, efcnetwork.org. And then there's an in-person workshop in Michigan for any of the folks who are on the phone, on the webinar in or around Michigan, or anybody who want to travel to Michigan for the leadership workshop on December 3rd and 4th. You can go on our website to read a little bit more about that and to sign up. We want to thank EPA for providing the funding for this project. And then finally, I'll put up our contact information, and we have a little bit of time for some questions. Dawn, if we have any questions, and if you have any, you can go ahead and type them in. If we don't get to all the questions, we'll try to answer them and send them out to folks. So Dawn, do we have any questions?
Yes, if we go back to the very first poll question, just a little bit of clarification, and you asked what characteristic best defines aging infrastructure, and the answer that you gave was useful life. And the clarification was just after the poll question, and you put up the next slide. The question was, so materials, manufacturing, and installation is also part of the answer?
Yes. Yes. All of those characteristics under useful life were all related to useful life. So all of those things, and age could be one factor you consider in useful life. It's just that we want to get away from just thinking about age and saying, okay, a pipe is 100 years old, it needs to come out, or a pipe is 50 years old, it needs to come out, to moving towards what is that pipe actually doing? Because sometimes a 100-year-old pipe is in better shape than, say, a 50 or 60-year-old pipe. Because it has more to do with, how that pipe was manufactured, 50 or 60 years ago versus 100 years ago, or what service that pipe was in, or what soil conditions or anything like that. So it's kind of just getting us to move away from the idea that it's just age to an idea that's a much bigger picture of useful life. So all of those characteristics relate to the useful life of an asset and how to decide what the useful life of an asset is.
All right, then there's a question asking you to please describe what the 300-year replacement cycle is.
Okay, what we're talking about there is that somebody is saying, if I put in a pipe in, say, 1900, if I replace it on a 100-year cycle, I would replace it at 2000. If I'm on a 300-year cycle, I'm going to replace it in, what is that, 2200. So I'm going to replace it 300 years after it got put in the ground. So when they say a 300-year replacement cycle, and they're particularly talking about pipe, I'm sure they're not meaning their pumps and their wells, because there's no way they could even be looking at that. But with their pipe, they're saying they're going to replace each piece of pipe 300 years after it was put in the ground. So the way they know that is by how much money they're investing in their infrastructure. So if you see how much money you're investing, then you can say, okay, how long would it take me to replace all the pipe at that rate of investment? And for them, it comes out to be 300 years. So what they're saying is, we expect each piece of pipe to still be operating, delivering service for 300 years. So in essence, they're saying their useful life is 300 years, which I believe to be completely unrealistic. I mean, I think that sometimes we use 75 to 100 years, and that might be short. I mean, there are many systems that have gone over 100 years, okay, but we don't really have any reason to believe that in most cases 300 years is going to work out. So what that means is they're going to have a lot more dramatic breaks like the one they had, because the asset is just going to give out. So the consequence is what they really need to worry about. If a pipe breaks and it doesn't have a high consequence, then they can replace it, no big deal. But if it has a high consequence, then the cost of repair is going to be 3 or 4 times higher than what it would have been to just replace that pipe.
All right, we've got several more good questions, but I wanted to we've got several questions coming in about if the webinar is available, if the slides are available. So I just wanted to remind everyone that they will be available on our website, efcnetwork.org. So you can get a copy of the slides, or you can view the webinar or share it with anyone that you would like to. And again, that website's efcnetwork.org. All right, other questions. Questions about useful life, determining useful life. Do you use video cameras? If so, is it expensive? How do you determine useful life? Those kinds of questions.
And I think you can use any tools available to you. There are ways to video your pipe, for example. It can be very expensive. So you wouldn't want to do that necessarily with every single pipe in your system. You would want to go back to the risk again. So if we think back to when we were talking about the riskiness of an asset, which relates to, is it likely to fail and is it bad if it does? Those riskiest pieces, you might want to put a camera in those pieces of pipe. If you just select a few pieces and you put a camera through it, that could tell you, what's actually happening inside a pipe. And many times people find out that the pipe isn't as bad as what they think it is once they put a camera in it. There's some leak detection things that you can do as well with, putting stuff inside a pipe. There's other ways to determine it because it, as I said, it can be expensive to use those technologies. You can do above ground technologies where you're just listening for leaks. There's several technologies for different size pipes that you can use, and that can tell you if there's leaks occurring. It won't tell you degradation necessarily. There's some other pipe technologies, again, that can be done above ground that will start getting at pipe thickness, but you know, you still have to do a little bit of work to say whether that thickness matters a lot. There are things you can do for the pipes that have the steel around them. You can, the wire breaks, you can check for wire breaks. For assets you can see, you can do visual inspections, you can do vibration analysis, you can put a camera down a well. There are techniques you can use to start getting at condition and useful life estimate, and you don't want to go crazy spending gobs and gobs of money determining the condition if that takes away from your ability to replace an asset or do something else. But you do want to put, you know, as much effort as you can into that, and again, based on risk, you'll put more effort, more money towards an asset that's riskier, less effort, less money to an asset that's less risky. So if you have, say, for example, one well, and that's the only well for your whole system, I might think about, you know, getting some analysis of that well, hiring somebody to come in and put a camera down the well, you know, do some analysis of it. So you're going to, those things that are on the level of service, the useful life slide, looking at things like, you know, what do you know about the pipe material? What do you know about its repair history? What have you known about the maintenance history? If you haven't done any maintenance on your asset, you'd probably shorten the useful life. If you've done a lot, you might lengthen the useful life. So a lot of those things would go into your useful life estimate.
All right, I wanted to let everyone know that we would really appreciate your feedback. There's a survey link that just popped up in your chat box, and it will also be included in an email that we will send to you shortly after the webinar is concluded. So if you would, we'd appreciate it if you'd take just a few minutes to complete that that survey so that we can improve upon what we're doing. Heather, we have many good questions that are coming in, still coming in. And we are out of time.
I would say we could probably go an extra 5 minutes just because I lost everybody for 5 minutes. So for those of you who are willing to stick with us for 5 more minutes, I think we could maybe answer just another couple in that 5 minutes, and then we can provide written answers to the rest.
Okay, so a couple of questions are similar in educating customers. Do you have any suggestions for educating customers so the higher rates to cover infrastructure replacement are justifiable to them? And then similarly, how do you convince a community that it's an investment versus a tax?
I think part of it is the change in language. One of the things that I've actually thought a lot about, and I did a TED Talk about this as well, about, you know, to customers, like how do you value water so that they're willing to pay? And the interesting part is we know people value water very, very highly. We know that based on what they'll pay for bottled water, where they'll pay 1,000 times the cost of tap water when they buy a bottle of water, which shows that they truly value the water that's put in a plastic bottle. And why do they value that? Well, it's because of the messages that have been put out there. And it's really time for us to change the message. We've done kind of a disservice to ourselves because we've spent a lot of time, you know, apologizing for what we've charged, telling people that they, you know, kind of instilling in their minds that they shouldn't have to really pay a lot for water, instead of saying, look, this is a service, you really need to pay for it. So I think a large part of it is to change the dialogue that we have with customers and really believe that it is an investment. We have to believe it ourselves, those of us in the water utility industry. We have to believe it deeply within our soul that this is an investment, and charging somebody for water is not a bad thing. It's a good thing. I mean, think of all they're getting. And I was thinking about this, you know, most utilities' water is so cheap that you could get a gallon of water delivered to your house at high quality for less than a penny. And think about, is there any other product you could buy anywhere that would be less than a penny? I mean, I can't think of anything. Even gumballs cost 5 cents. I mean, there's like nothing you can buy that's less than a penny. So we're delivering this amazing product at a very cheap price, and we can't sustain that forever. I mean, we still have, even if we raise our rates, the rates are still going to be low compared to many other things like filling your gas tank and paying your electric bill or your cell phone bill or whatever. But I think most of it is changing the dynamic of the conversation and truly believing it's an investment and starting as a whole utility to start making that pitch that this is an investment, and it's going to take all of us to start changing that dynamic and, you know, setting rates that, you know, are maybe above what some in the community can pay, but we'll have to have a program in place to help them, but set rates that are going to get us the finances we need for the rest of the community, and then we'll have to have affordability programs, which will actually be talked about in a future webinar, to address those customers that are, you know, lower income customers or don't have the ability to pay. Typically, though, the ability to pay is much higher. It's the willingness to pay that's lower, and that's the part we need to work on, is that willingness to pay.
Is there a charge to communities for asset management plans?
There doesn't have to be. I'm a firm believer that the more you do yourselves as your own system, the better off you will be, because you will understand it, you will own it, you will implement it. So you can do much of it, if not all of it, by yourself. Maybe it's a lower level sophistication, but that's okay. Maybe your map you have to hand draw on an aerial that you get for free from your county versus a GIS map. And that's okay. I mean, it's okay to do it at a lower level. So it doesn't have to cost you any money. There are resources. We have an asset management guide that we'll send out to all the attendees that helps systems. You know, it's sort of a guide with videos that will help walk a system through how to do an asset management plan. And you can take it on yourselves, and you can do a pretty good job just by yourselves. If you choose to maybe contract out a piece of it later on, you can do that, but I'm a firm believer that you can actually do a pretty decent asset management plan by yourself if you have just the desire to do it. That's the main thing. If you have the desire to actually sit down and work on it, it will pay dividends, and the more you put into your plan, you know, meaning the more components like the current state of the assets level, service criticality, etc., the more you do, the more benefits you will receive. But if you do it, you will reap benefits from having done it.
All right. We have had several questions come in about CEUs as well. And just as a reminder to everyone, there will be information on how you can print your attendance certificate to submit to your state in the email that you will receive following the webinar. So if you are interested in receiving CEUs, make sure you look for that email. And I think that we are officially out of time.
Okay. Well, thank you all, and I apologize for the brief glitch in the audio. I don't know what happened. Like I said, for a whole half an hour before you guys got on, it worked fine. So that's technology for you, but I appreciate everybody being with us today. We will have the recording up on our website, and we will get answers to the remaining questions out to you to follow up as a follow-up to this webinar. So thank you, everyone, and have a good day, and hopefully we'll have some of you next week when we do part 2.